Yeah, so right now I'm an associate professor here of doing geospatial at the University of Tennessee, and I got my PhD in geography in 2015. And so this is I finished almost 8 years working at the academia, and from tenure track assistant professor, and recently promoted to tenure professor just 2 months ago. And so I do teaching in geospatial, mostly doing programming, open source software development, and also some public education. So I also create packages, creating tools, making videos. Basically, it makes my life easier for myself. But in the meantime,
Nice.
if it benefit other people, that's great because I have to teach my student how to, utilize this geospatial technology, cloud computing. So initially, I was just building the tools for them, like makes it easy for me to teach, and looks like the community like it. And then so I post more to GitHub, and then so now my daily life is basically adding new features to those packages, answering questions from the community, and when I have time, I record the videos, just introducing those new features. So that's something that I enjoy doing. I like
Yeah.
seeing people utilize some of my open source packages and then build their own applications. And I also like love working with the community, how to make those packages, open source tools, even better. And that's one of the part is that I also appreciate those open source packages like Streamlit, that makes it
Nice.
easier for me to like make my data products accessible to other people. Because one thing I really like is that we need to lower the barrier that other people can actually try out your stuff. Otherwise, it's just on GitHub. Nobody know how to put a GitHub repo. Nobody how to actually spin up a server. And,
Yes.
and packages like Streamlit, Solara, and other web mapping framework. It makes my life so much easier.
We know probably we've heard about geosciences,
Mhm.
but why is it important and why should we care about it?
Yeah, of course. We use geospatial technology or geospatial data all the time, but people usually are not realizing that they're using that. So one simple example: if you use Google Map, Google Earth, Apple Map, whatever, or even Uber, Lyft, right? You're taking a ride.
Yeah.
Those are, behind the scene is dealing with tons of geospatial data. So anything that you're dealing with, location, your phone, for example, checking your
Yeah.
daily activities all the time, your location, and behind the scene they run all kind of analytics to figure out where are you going, where are you shopping, and then what things you buy, what location you visit, right? Those are tons of like business opportunities. So most of the companies or government agencies, they're utilizing those geospatial data to analyze patterns and over, for example, disaster management, right? So if
Yeah.
something happened, for example, earthquake in Morocco or flooding in Libya or whatever, like you need some of those geospatial data to help you make informed decisions, because sometimes those locations are not accessible anymore. So without a satellite, you cannot actually see what's going on. So with those satellite data and also lots of like open geospatial data, people can be more aware of what is going on and what's going to happen and how do you mitigate the damage, something like that. So with that, if you have that kind of skills, you're going to make way more informed decision. Or even maybe a more real life example: you're trying to buy a house, right?
Yeah.
Location is very important. Or you're trying to rent an apartment, right? Where do you
Yeah.
rent, right? How is it convenient? What are the nearby school? What are the crime rate, right? Those are all dealing with geospatial. So I'm 100% sure if you are a human being on Earth, you are interacting with some geospatial stuff, but you just may not realize you are doing that.
Yeah.
And so that's what my mission is, to actually increase the awareness of this geospatial data, geospatial technology, or even cloud computing.
Do you have an example of a project or an app that you
Mhm.
use Streamlit, where Streamlit kind of played a crucial role in your app?
Yeah. So one app that I created was called like time lapse. Right. You use Streamlit to pull satellite data, create some simple animation, and that one I think was quite popular. I did it initially 1 or 2 years ago, and it's
Okay.
still running. So people are visiting the website all the time, creating animations. If you want, I can show you
Yes.
the screen. So it will be something like this. For the audience, if you like, just search Streamlit Geospatial on Google. You should be able to find all my apps and all the source code. Everything is open source, and this is one of the most popular one that I created. It basically allows you to create animation using a lot of satellite data. Under the hood, using Gmap and Google Sensing. So Gmap is a package that I created for doing interactive mapping with Google Sensing. So you can check out the links in here, and it's pretty very easy to use. You also have the, for example, the demo in here, if you want. So this is on from the YouTube demo. All you need is basically zoom to anywhere you like, and then simply draw a rectangle or a polygon, and then just select whatever satellite you want, different band combination, and then you can just adjust some parameters. Then you should be able to create animation for you. So within 20-30 seconds, then you get the animation in GIF format or MP4. Then you can download it to your computer. So this simple example here just show you, for example, how the river dynamics, and that's kind of things that I mentioned earlier, like the surface water, the dynamics is changing all the time throughout the year, throughout
Yes.
the decades, and how to actually monitor them rather than like most of the map you see online. It's just one snapshot, but it might not be the most up to date. And you can just upload any hour you like, and then just select. So, for example, this is another example of. Can you still see it?
Yes.
For example, like the Hong Kong airport, right? So we have
Yes.
data every year, and you can easily see the changes of the landscape. So this is the longest satellite data archive that we have since 1980s and up to right now. So every 2 weeks, for example, you get one imagery. So we get data, global coverage almost every 2 weeks, and we have more and more satellites. So now you can even get like weekly data, and also here you can see you can download as an MP4, something like that. So pretty
Nice.
easy to do. You can do that for any location, so it doesn't really matter. And the nice thing is that it's just simple. Find your location you like, and then you can create easily. Before like cloud computing, like this take you hours or even days just to create. You might look so simple, but you can imagine like remote sensing, low satellites, sometimes affected by cloud. So you might not always get like cloud-free imagery. So you have to basically every year you're dealing with maybe 10, 20 images, and you're trying to create the best one without cloud. And then you want to download all of them like for multiple years, for decades. It's going to take a lot of data storage and also do data processing, removing the cloud, and get a better version of the animation. But now 20-30 seconds, right? No coding, nothing. It's just automated. So if you're interesting, you can also look at the source code, for example, on GitHub. It's open source, so you can try out, for example, and show you the pages. And then so the second one, the first one, right?
Yeah.
It's Pandas who is using Streamlit and Gmap, but you can take a look at that, right? So I wrote like thousands lines of code just to create like simple web app, but now everyone can go online. They don't have to like do the coding themselves, and it's just so much easier. It's not just for Landsat. You can use tons of other satellite data. Maybe I can show you another one here. For example, vegetation. They
Yes.
say, okay, I'm interested in studying vegetation, how the vegetation changes. You can draw a rectangle, or you can just select a sample area. For example, I'm gonna look at the vegetation changes in Africa, for example. And then usually you can just use the default settings. You should be able to create those animations. So under the hood is going to the cloud and pull all the data in, and then do some data processing, and then download the data based on the visualization criteria. Take a look, right?
Nice.
Within 20 seconds, you see something like this. This you won't be able to like do that like on the ground because it's
Yeah.
like longer time scale, and can clearly see like how the vegetation is changing throughout the season. It's quite interesting. Just like
Yes.
the nature is life. It's like
Yes.
human, just ranging like it's changing throughout the season. Not just vegetation. You can do even, for example, um, hurricanes, volcanoes. There are all kinds of things you can capture. So satellite has a variety of like spatial resolution and temporal resolution. It's up to you what you want. Let me show you another one. Maybe the Go satellite. So this
Yeah.
one is like oops, no, here is very high temporal frequency. So you can get data, for example, every couple minutes rather than every 2 weeks. So it depends on your specific requirement. You can select the satellite data suitable for your application. And then for specific data, so for example, this is the volcano eruption. This one has a lot more data because you have data for every 5 minutes. And if you want to capture something that happen very quickly, then you will need some of this data. Take a look, right? And
Nice.
now you see the volcano eruption, like in Tonga, I think January last year, right? And
Nice.
so much easier to use. I mean, again, it depends on what things you're interested in. It can be hurricanes, it can be volcano, it can be even earthquake or anything. As long as on the Earth surface, it can be captured by satellite. Low satellite data usually in the public domain, you can do it. So, and this is one of the things that you see on the social media, on TV, look at those animations. So now you can create one by yourself.
I'm Elwynn Chen. I'm the founder of Canaries Data. So I may add some more background of the open source project we've done. So we built data visualization softwares and data science softwares in the open source community. We mainly have 3 open source projects: Canaries RAS, Canaries PyGwalker, and Canaries GraphicWalker. Yeah. So the first project we built is called Canaries RAS, and it was back to my college life. Yeah, at that time I was researching about some fundamental theory about graphic system and the visualization framework.
Okay.
So kind of like the grammar of graphics, which is a fundamental theory behind Tableau. Yeah, and at that time when I was trying to design the graphic system, I find that even the software like Tableau, they're extremely powerful, but it still requires a lot of manual work for the end users.
Yeah.
Like you need to figure out what variables you need to pick, and you need to figure out what encoding strategies for the visualizations. Yeah, so still a lot of work. So I'm thinking about whether we can make the whole process of data exploration more automatically. So that's the basic idea behind RAS. So I built a prototype in college, which is the prototype of RAS, which turns the you just upload the tabular data set to RAS, and RAS will trying to explore the whole data sets and find interesting patterns and relationships in that data and pick the best visualizations for those patterns. So basically, you just put data in, and visualization will be directly output. So you don't need to do all those manual work in Tableau or Power BI stuff.
Okay.
Yeah. So I put a lot of time on to optimize that prototype of RAS, and then I trying to extract some of the components from RAS and launch those components independently from RAS to allow more people to use them, maybe more flexible. So the first components I get from RAS is GraphicWalker, which is my second open source project.
Okay.
So GraphicWalker is the open source alternative to Tableau. So just open source alternative.
Okay.
Yeah, but it's a more light alternative. It's not a heavy BI system. It's just a React components. So anyone can integrate that components in any kind of different system, and just with a few lines of code. And GraphicWalker will handle all the data source you put into, handle all those computations, how to transform interaction into visualization, handle everything for you. But it's not an independent large BI system. It's just a component. Yeah. And then we build a Python wrapper based on GraphicWalker. So it is the PyGwalker. So PyGwalker is actually called the Python binding of GraphicWalker, which maybe you should call it PyGwalker.
Yeah.
You can pronounce Y as I, so it's called PyGwalker, which is more interesting. So what PyGwalker does is, it in Python, it can turn a data frame into an embeddable interactive visualization module in your Jupyter notebook or just any kind of Python environment. Yeah.
So I think we're ready for the demos now.
Yeah.
I'll pass it over to you to kick it off.
Okay. Start sharing.
All right.
Okay, so I'm just going to do some basic tutorial of PyGwalker. And here I have a dataset called Bax dataset, which is a very simple CSV dataset. And I'm using Pandas to import this data frame. And you can see this data frame is actually have some rows of temperature, filling temperature, or the users, casual users, registered users, something like that. So usually, maybe when you want to explore this data, you may need some matplotlib or Seaborn code to try to test different kind of collaboration combinations of variables. Yeah, but with PyGwalker, after we import PyGwalker, you can just use in one line of code, which is PyGwalker.walk, the data frame. So this will turn your data frame into a embeddable module, and you can have a brief view of your data sets here. So you can see all those variables distributions and some basic information of the rows. And then we jump into the visualization module. For now, you can just using simple drag and drop to visualize any variables you want. For example, I can check the distribution between casual users and registered users with a scatter plots, and I don't need to code anymore. And I can make this visualization larger. And for example, I want to see the distribution between different seasons, or I can split them into different facets.
Okay.
So this is very fast visual exploration, and you don't need to code anymore, and you can just focus on those patterns in the data.
Nice.
Yeah.
And
yeah,
this reminds me of QuickSight on AWS. For those who are not familiar with QuickSight is just a visualization tool on AWS as well. I played around with it, and it reminds me of the drag and drop system. And I'm sure there's so many other examples that kind of work the same. But I think this is really cool, being able to code this on even a Jupyter notebook and have some of this features already available.
Yeah. And also we have, you can see we have a GPT power feature, which allow you to ask some questions in natural language. And for example, I can ask, show me the relation between temperature and fueling temperature. And sometimes you don't need to use drag and drop, and you can just ask questions in simple text prompts, and it will also directly generate those visualization for you. So especially for some visualization, you don't want to figure out what variables you want to pick. You just want the GPT to figure out what variables to put where. You can just ask questions directly.
Okay. Yeah. And so the ChatGPT portion of it, how is it working in the back end of things? Is it also just kind of doing the drag and drop, or how does that work in the back end when you ask a question, for example?
Yeah. No matter it is drag and drop or GPT, maybe you ask questions, everything was just translate into a specific language which is in a JSON format. Yeah. The language actually called GraphicWalker. Yeah, is a DSL in GraphicWalker, domain-specific language, special for GraphicWalker. So it describes the visualization structure special in GraphicWalker. So all those drag and drop operations will be turned into a GraphicWalker specification, and all those natural language will be turned into a GraphicWalker specification. Yeah. So everything was just a JSON specification of GraphicWalker here.
Oh, cool. Awesome.
Okay. And for this, I'm going to dive in a little bit deeper of this visualization. So you can see that there's a positive correlation between fueling temperature and temperature, but there's a outlier clusters here. So let's try to solve this problem. So we can see some of the data that the fueling temperature is negative, but the temperature is definitely positive. So I'm assuming those data are some dirty data. They're totally not correct.
Okay.
Yeah. So after we match some kind of dirty data, we want to clean them. We want to drop out those data so they don't affect an analytic result. So maybe traditionally you need to write a lot of Python code, but in PyGwalker we have a very easy to use tool called data painter. And here you can use the data painter with a contains an eraser and just delete those data. And those data are just gone.
Okay. So that's very cool. And so when you're like painting over and deleting that, is it just kind of creating another copy of the data frame in the backend and taking out those pieces, or is it just kind of altering the main data frame itself as well?
Yeah, it actually just add another column of that data frame. That column is kind of feature or labeling column. It shows whether this row of data it should be removed or not. After that, if for example I drop all those dirty data and I want to use those data for further analyze, maybe for machine learning or some kind of stuff, you can click export. So here is a button called export data frame, and it will just export clean the data. So the PyGwalker is actually, I put this in a variable called walker, and the export data frame, you can access it as here, walker.latest last export data frame, and you can see this is a clean data frame. And you can also visualize this data frame to check whether it's clean or not.
So you did a PhD in number theory at Cornell before you joined Microsoft, where you worked on the experimentation platform. You built a new multi-target compiler. Not gonna lie, I don't know what that means, so would be interested to know. But for creating experiment analysis code, you also helped get better support for privacy-preserving ML techniques like federated learning into the platform. And now you work at Airbnb as a staff data scientist, with a focus on aligning data science and machine learning to use tooling that makes collaboration and rapid iteration really easy and scalable. So before we get into how Airbnb uses Streamlit internally, I'd love to know more about what data science in general looks like at Airbnb. And I'm sure there's a lot of variety depending on what team you're on and what that team is focused on. But what kinds of questions in general are data scientists at Airbnb focused on answering?
Yeah, that's a great question. A couple kind of general examples I can talk through. One, Airbnb has a lot of users that have to kind of walk through a journey before obviously the platform can bring them value. So think a guest interacting with customer support, the journey being their problem is solved, that being the end state we want to get into. If you think of a new host onboarding, obviously, what's their journey? There's a lot of steps there. And so one kind of area where the data science community spends a lot of work is how can we visualize that journey? How can we bring machine learning to bear to make predictions there? Just generally deeply understanding that. Another one is A/B testing specifically, but more broadly, observational causal analysis for things like Airbnb's company-wide launches. If you Google those, you'll see a lot of exciting stuff from our CEO. From a statistical perspective, they're surprisingly challenging to understand if you just launch something all at once. Our recent contributions to last year's KDD talked a little bit about some of the statistical techniques there. And then beyond kind of user journey, causal analysis, broadly, just deeply understanding, the customer experience, the marketplace dynamics. Airbnb is a two-sided marketplace. Right. And not just data scientists, of course. These are all questions that the whole company is deeply concerned about.
Yeah, that's interesting. I think so. Kind of looking at us, the users on Airbnb, and where they're going on their journey of I'm looking for an Airbnb in North Carolina in April, and spent hours looking at it and doing different searches and trying to figure out how people get to actually find the place they're going to book and go through with that. That's really cool. So the Streamlit team was really excited to hear that Airbnb is using Streamlit internally, and that you actually have a ton of apps. You have somewhere around 100 apps, which was just like super exciting to our team to hear. What are some of the most common use cases that you're solving for with Streamlit?
Yeah, so thinking back to the data science questions I talked about above, data science is hard and it takes a long time. And if a data scientist has an idea that they think will partially solve or help in one of those problem spaces, but it's just an idea, they're really not sure if it has legs, it's insanely powerful to be able to not just show your leadership some machine learning metric difference, I don't know, 90% accuracy versus 95% accuracy or something like that, but instead to show them, here's what the idea can do, whether that's a different way of visualizing the user journey, a different, if it's some machine learning. What is the model actually doing? Can you interact with the inputs and outputs? That tangible nature of bringing an idea to life and letting execs interact with it, even if maybe it's 20 lines of code that someone hacked together, that's okay. It lets them really get a sense for what's the product potential, even just from a scientific perspective. Does this idea have legs? Without spending months and months of time, building out something only to realize it doesn't have a lot of potential. Also, the lingua franca of data science and machine learning tends to be Python or Jupyter notebooks, and I cannot share to an exec a Jupyter notebook and say, hey, look at this. I think that's probably true of pretty much any company, but you can definitely share a Streamlit app, a live Streamlit app with someone in the less technical arm of your company, and they'll still be able to, again, that tangibility, being able to interact with it is super powerful.
So we're also going to get the chance to see one of these apps that your team has built internally in action today in a live demo. So tell us about that app and let's get into the demo.
Yeah, so I'm intentionally sharing something that's kind of as generic as possible. There are a lot of generative AI models out there, and it can often be challenging to decide, do I want to use one of these models versus another? So I'm going to demo an easy way to just compare if you're using any of these models. Let me see. Oops, that's the wrong button. Sharing screen is always the thing. Yeah, perfect. So people can see here. I've selected a specific model. I have a question. I'm giving some instructions to a model, and I'm going to change this so we don't get a pre-cached answer. Let's say instead of Belgium, let's say Spain. Blah, I'm going to be able to see an answer here, and then I can compare to, I don't know, some other model. And it looks like that model's broken into backend.
The demo gods are not with us today.
Yeah,
so.
but that's part of the value of prototyping, is you can try out ideas quickly and iterate really quickly.
Yeah, absolutely. Love that, and I love how the styling is also, you look at it and you're like, oh, this looks like Airbnb.
Yeah,
so
I guess, yeah, and that's a nice thing. I mean, I guess I would say about Streamlit being a pretty general framework, it's easy to add customization and hooks as far as custom CSS or color schemes or that kind of thing.
So can you tell us about OneBrain and how it solves this pain point for Airbnb's data science teams?
Absolutely. And I'd say for folks who are interested to know more, we wrote a bit about and presented about OneBrain and KDD last year. So there's a full deck that you can go take a look at. But yeah, in a few words, OneBrain takes your data science code, whether that's R, Python, or other things, and with as little kind of boilerplate or overhead as possible, magics away that little bit of engineering muscle you need to cross, platform or repo boundaries. So things like dependency management, configuration, CI/CD. OneBrain gives you all of those things for free, whether your code is a Python package, an R package. We have like joint Python, R, and TypeScript packages that all have shared code. It could be a web app using Streamlit, or there are other great web application frameworks out there as well. But the key part then is, as a data scientist, you don't have to worry about like, does a platform have the same dependencies as my code? Because all of that is taken care of for you. It's been super powerful internally, making sure that not just Streamlit apps, but scientific code in general is easily reproducible and easily shareable, again, across those kind of platform or Git repo boundaries.
Yeah, and so in terms of what it actually is it is part of it just having like the standards for how the data scientists work, or is it like an actual package that's on GitHub that your data scientists,
Yeah, no, that's fair. I should beyond kind of just the generalities. Concretely, it's a CLI. You can kind of think of it as pip for data science code. You can run. There's a brain command. You can run brain. Run to invoke your code locally with that dependency bootstrapping and configuration logic, or you can run brain run with a reference to a project remotely that'll bootstrap the source code of the project and all of that same dependency management and configuration management. So there's that CLI that you can run locally, but then it's also integrated into Airbnb CI/CD, so that as long as you check in a OneBrain, we call it a project file. It's just a YAML file with a few lines of like, what is the name of your project? What are the dependencies? you'll get a lot of that extra CI/CD for free, so that the CLI can bootstrap your source code from anywhere. Hopefully that helps. I think thinking about it, it's kind of pip for more than just Python packages, because data science code tends to be kind of a little bit more language spanning.